guys, today we're gonna learn on how to um, solve for a variable in Tetration. Makes Tetration equations. Okay, so it's actually a multiple operation, including Tetration itself, an exponentiation. So let's say if I have 2 iterated to 2 raised to the x squared, 2 iterated to 2 raised to the x squared. Hold on. I gotta move the 2. I just gotta move, now it's better. 2 iterated to 2 raised to the x squared is equal to 16. How can I do that? So first, on my previous video, I just used the common base. So the common base between 2 and 16 is 2 because 2 iterated to 3 is 16. So let's go replace 16 with 2 iterated to 3, okay? Now, for that, I can make the Tetration heights or Tetration x1 is equal to each other since we have the same base. So 2 raised to the x squared is equal to 3. To solve for, I don't know what the common base, I turned this Tetration equation to an exponential equation. And then, I don't know what is the common base between 2 and 3. What do I do, you might ask? Use logarithms if you don't know, okay? So since we're finding the exponents, we're using logs. If it was like a base operation, it's gonna be radicals. Okay? So I gotta take the logarithm on both sides. Log base 2 on both sides, I forgot. And then the 2's will cancel, giving us x squared is equal to log base 2 or 3. Here's the most important part. Whenever you have like a x squared is equal to something like, let's go say 16. You know, what is it? 4, but it's not just 4. I'll do it to you. You also need to take the plus or minus root of both sides. Plus or minus square root both sides. And then the 2's will cancel, giving us x by itself. X is equal to plus or minus, square root of 16 is 4, because 4 squared is 16. But how does negative 4 squared equal 16? Well, it's actually in parentheses, because what I'm seeing here is negative 4, even the negative sign is applied. We are multiplying 2 negatives. That gives us a positive. But here's the most tricky part. This is not equal to this. I know, confusing, right? Because negative 4 squared is equal to, this doesn't apply the negative sign. So I just gotta write a negative 1. Negative 1 times, this actually equals negative 1 times 4 squared, or negative 1 times 4 times 4. And I want to do that part. I know negative 4 times, that was like a negative. Okay, so negative 1 times 4 is negative 4 times the 4 is negative 16. So, yep, those are actually complete opposites. Okay? It's actually with parentheses. Okay? So I need to take the plus or minus root of this side. Okay, the 2's will cancel, giving us x by itself. X is equal to plus or minus root. I like writing my plus or minus signs right here. X is equal to plus or minus. Yeah, that's how I write it, okay? Make sure you write it like that so you won't get confused, okay? X is equal to plus or minus root log base 2 or 3. That's the answer. And now it has a mixed operation. I see square root and I see a logarithm. That's cool. Interesting. Then what if you have like a similar equation? 2 iterated to 2x squared gives us 16. I know what I can use base 2 for 16. It's because it's 2 iterated to 3. So 2 iterated to 3. And then I can just apply the same rule. 2, if the bases are the same, that means the exponents must be equal to each other. I mean, the tetration heights must be equal to each other. 2x squared must be equal to 3. Now, I want to get x by itself. We're just solving for x squared first, so we're just dividing both sides by 2. Now, these will cancel, giving us x squared is equal to 3 over 2. But when you plug it in, 2 times 3 over 2, 2 times 3 over 2 is, the 2's will cancel, giving us 3. No. Hold on. No. I can replace x squared, that over here in box, with 3 over 2. So 2 times 3 over 2, the 2's will cancel, giving us 2 divided to 3, which equals 16. So x squared is correct, but we need to find x. So I need to take the square root of both sides, even the square root of the whole fraction. It will cancel, giving us x is equal to the whole square root of 3 over 2. Now, square root property. Square root of a over b is equal to square root of a over root b. You might learn this. Okay? You might learn square roots or radicals in another video. Okay? So, this equals root 3 over root 2. Now, I don't want a denominator and radical, so I need to multiply both sides. I might make a video about this next video. So I need to multiply both sides by root 2. By the way, I want the signs to cancel. So 1 plus 1 is 2. There's an invisible 2 over here. And then 1 plus 1 is 2. That's how I want to get like a whole number into that fraction in the denominator. So 3 times 2 is 6. Keep the radical sign. Square root of 6 over square root of 2 squared. 1 plus 1 is 2. And then the 2's will cancel the indexes, which equals the square root of 6 over 2. Yep, that's the correct answer. Bye, guys. But you need to be careful over here. Plus or minus. So, and minus and negative square root. Hold on. This is not the end of the video because if you forget it, just gotta correct it, okay? So, and negative square root 6 over 2 2, which equals, if you have both positive and negative, you can just write plus or minus root 6 over 2. This is actually the answer. You can actually write this as the answer, negative square root of 6 over 2 and square root of 6 over 2. But just to make sure you always do that plus or minus root. Okay? But you need to be careful in some cases because you might get incorrect. Bye guys! This is the whole end of the video. Bye!